Hi, it's Joe, ZL1PMY, and today on the bench we've got an IC756 Pro III, and that's come in with a whole list of faults, including one I'm going to show you now. We're going to tackle all the faults, of course, but on 160 meters and down, when you get into the broadcast section, the owner is complaining of lack of sensitivity. So if I turn the volume up, we've got the signal generator set at 1.6 megahertz, and there you can hear the signal generator working. So we take that down to 1.59 and we adjust the signal generator to 1.59 and there's nothing. So within that one step, you lose the sensitivity of the receiver. So what I'm going to do now, up on the signal generator, the test setup here is that we're into a dummy load with a 10 dB tap. So I'm going to come down here and dial in 1 millivolt of signal, 10 millivolts. And at 10 millivolts you can hear just, you know, the receiver is working, it's just very deaf. So the other fault it's got, if I dial say 28550, and I'm trying to do this with getting the camera cord in the way. So if I go to transmit, and you can see there the running low power. If I turn the power up, so that's 25 watts, 50 watts, 100 watts. So you would think that all seems to be good. Come out of transmit and just engage the tuner without actually making it tune. Go to transmit and you get a complete reset of the station because the PA probably has sucked up a lot of current. So it's not obvious why that would be. We're going to have a think about that. The lack of sensitivity on the broadcast bands may indeed be a menu setting somewhere. Certainly when you go on the broadcast bands you need to deselect the tuner. We'll go back to the broadcast bands, and you know, the tuner would get in the way. I think we're 1.59 at the moment. Just take that down, 1.59. Well, that's at 10 millivolts. If we go to the normal, let's just put 10 microvolts in, which should be adequate. There's nothing at all. So I spoke in my last video about commonality of faults. This has a little commonality in that we've got a lack of signal on receiver in one band, and the transmitter crashing out on another. Let's just go to 24 megs, and again deselect the tuner, go to transmit. There you can see we're running 10 watts. Go out to transmit, put the tuner in and transmit again, and you can see the needle's gone full over and it's reset the radio set, you know, because the voltage has dropped so far down that you know, it's not coped with it. So there you have it. So the next thing we'll do is pop the lids off. I think what we'll do next is just check the manual to see if there's a setting for broadcast. I know with the automatic antenna tuners, especially the marine ones, there's a jumper you put in place which bypasses the tuner completely, so you can listen to the broadcast stations. So we'll see if there's anything peculiar in the radio set regarding that. I'll get back to you. So we've got a receiver that appears to be deaf at any frequency below 1.6 megahertz, i.e. the broadcast bands, and we've got a transmitter that shuts down on any frequency above 18 megs, I think it was, where you engage the tuner, even if the tuner is not tuned. So I thought we'd have a look at the receive fault first. I'm not sure there's a commonality between the two. They both use switch filtering, but it's not the same filtering at the same time, so we'll have to look at it as independent faults, and then come back and have see if there's any commonality, see where we end up. So one of the best places to start is the block diagram, and here you see the antenna distribution block diagram, the front end. So just explaining, blue is common to both transmit and receive, green is receive only, and orange is transmit only. So you can see here on the right hand side you've got your two antennas, and there's an antenna changeover relay. This is when you push the front button on the panel, antenna 1, antenna 2, etc. And then the tuner may be switched in and out of circuit, i.e. not used. The 756 ProIII has a separate RX antenna if you want to use it, and there's a relay here that swaps between the normal antenna 1, antenna 2, and using a special receive only antenna and still transmitting on one of the others. So following the green line, common to all circuits, there's two attenuators, 6 dBs and 12 dBs, and if you switch them both on together you get 18 dBs. And here is where the thing splits. It uses diode switching, pin diode switching, and you can see that if you're using an amateur band frequency, then the receive antenna signal goes through one of the bandpass filters, which are switched in and out of circuit by logic. But if you're using the broadcast bands, i.e. listening only, these are switched out of circuit, and your signal then goes through a fixed attenuator and a fixed low pass band filter, and that's switched into circuit by logic signal B0. So these filters, and I don't know if you can see the legend or not, we've got 1.6 to 2 megs, 2 to 3 megs, 3 to 4 megs, 4 to 6 megs, etc, etc. And down here you can see the logic number that switches them, B1, B2, B3, B4. But to use the broadcast band facilities, it's B0 that turns on this filter, and in particular it turns on that route. And this line goes off to another section that is common to the broadcast bands only. So we'll take a look at that. So here's the same thing, but the actual circuit. So this is your relay that switches over between the receive only antenna and the one of the pre-selected antennas. There's a relay, and then you've got the two attenuators here, 6 and 12 dBs, and when the relays are energized, those attenuators come into force, and when they're not energized, the signal goes straight through. And at this point here we've got the diode switching, and there you can just about make out a diode. Now diode switching, I may do a video on that later on, but essentially if you put a positive voltage on the cathode of a diode, you turn it off, it won't conduct, and so by energizing this line you turn this path off, and so the received signal is forced to go that way, and that then leads to the broadcast amplifiers, if you want to call them that, the broadcast route into the receiver, and that's the one that's giving us problems. I'll see if I can get this off. I've got all this propped up on my laptop. So the broadcast signal comes along this green line, and here you can see, I don't know if you can see or not there, there's a diode there, and there's a diode at the end here. And B0, the logic signal B0, is applied through these two resistors, which turns on either diode respectively. So the signal then comes along this path. You've got a low pass filter here, and you've got an attenuator here. Those are the two components we saw on the block diagram. Now after this point we've got everything that's in circuit is common to both amateur bands and broadcast bands, so it's not likely that the fault is after that point. So here is the signal from the broadcast band, and then this block is one of the preamplifiers. There are two preamplifiers in the radio, and preamplifier number 2. Again, this is all diode switched. You'll find that these preamplifiers you cannot select when you've got broadcast band frequencies selected, and so the signal continues along here, and at this point we split the signal into two paths. You can see these amplifiers are identical, and that's for your main and sub receivers. So all this is common to both amateur radio frequencies and broadcast band frequencies. Don't come that way, and the broadcast frequencies come along here and then through this little network, and so the fault must be somewhere back towards the antenna that's common only to the broadcast frequency, and it's likely to be that switching network, and we'll go back and have a look at that in a moment. So back with the circuit diagram, the receive signal comes in here, and it actually goes both ways, but when you select broadcast band, this diode should be reverse biased and goes high impedance, so the signal from the antenna goes this way, and it'll only do so if a diode in this line is turned on, and that's turned on by this chip, which has all the bands B1, B2, B3, B4, etc. for the switch bandpass filters, but B0 is the one we're interested in, and that will turn the diode on back here and also the output diode, so the signal goes through this network. So if we're suffering a great loss of signal, it's either that the diodes aren't being switched or have gone faulty, B0 isn't present, or we have a problem with one of these components in this line. So if we can get to it, it would be an idea to inject a signal somewhere after this diode, directly from the signal generator, to see whether the sensitivity going forward, as we suspect, is okay. The problem with that is you don't know what impedance you're tapping into. The signal generator is 50 ohm, but these lines may be quite different in impedance. So I think we'll look for the B0 signal and then see if we can actually get to the two diodes that cause the switching. In fact, there's three. There's one here, one further back in this line, and then this one has to turn off. So we'll check that those are actually switching, haven't gone faulty. And the quickest way of finding those components on a printed circuit board is through the parts list, and I'll show you that next. So here we are, just having a quick look at the set. We know that the components we want are on the RF board A, and that's the whole of this card. I think actually it's RFB, got that wrong. And this is filter board A. This is the bandpass filter, which is switched when you're using the amateur frequencies, and switched out of circuit when you're looking at broadcast bands. This assembly here is the twin preamplifiers, which aren't used in the broadcast band. So it's quite likely that the bits we need to test are underneath these two, which are actually soldered in circuit, you can see here. So you'd have to desolder all of that to get it out. But there's just a possibility that some of the diodes we want to check may be on the underside, and that's where the parts list comes in handy. So I'll go over to the computer now and I'll show you how the parts list works. So I've got the service manual up online, and I can confirm that the larger board is RF-B unit. The A filter is not shown on here, it's a plug-in module. Now, one of the things with the more modern Icom diagrams, if you right click and click on find, then you can type in a component reference here, We know that one of the diodes we want is D104, which I've just typed in. Now these circuit references are likely to be used on more than one board, so you have to make sure in the parts list you're looking at the RFB unit. So I'll click on that and say next, and where the blue box appears there is one of the components will be highlighted. That will be that particular diode, but obviously this is a circuit and not the parts list, so you keep going till you get into the parts list. So this is at the top, it's RFB, and it's highlighted a diode there, as you can see. D104, it tells us what the diode is, but here on the right hand side, if I can slide it over, you can see that this diode is on the bottom side. B means it's on the bottom of the PCB, and these numbers are a grid reference, because around the PCB there is a scale. So on the bottom of the board, if we looked at 14.1 by 79.4, we should find D104. So I'll just jot those down, and then I'll switch off camera. I'll bring that board layout up and we can check that is correct. Okay, so on this particular manual, the text is searchable. So using the facility I just showed you, I went to the PCB layout for RF board B and started to look for D104, and here you can see it highlighted, but as you can see the coordinates are 79.4, and if we went across that way you'd come to 14.1. So even if the text isn't searchable, by following the coordinates you'll find the diode that you want to test or remove. Sadly, the other two diodes are on the top side, which means we've got to take the board out and take it to bits. But also we need to look for the logic signal, so we'll be finding where that IC is next. So I've drawn here the little bit of the circuit we're interested in. So the broadcast band RF signal from the aerial comes this way. When B0 is high, a current flows through that diode and through that resistor, and those chokes through that diode. So the pin diodes actually switch on. Consider them as a switch, and so the signal can pass through this network and through the diodes. Now you can see here I've put some component numbers on, and using the parts list I've identified what we can see from the top, and the components on the top are in fact 803, R803, R801, R802, and one of the diodes. We can't see this diode. The preamp board sits on top of this lot, and the RF filter board sits on top of that lot, but we can just get a peek here of R803. So if I go over to the hardware, and this is the switch filter board, this is the preamp board, and down through that gap we can just see R803. I'll try and zoom in. I don't know if this is going to work or not, but we'll give it a go. No, it's not going to focus. For some reason the cameras don't like to go out of zoom when you're videoing, or this one doesn't anyway. So yeah, what we're going to do is run some tests by accessing what components we can see through that tiny gap. So I'll get back to you shortly. I'll just set all that up. So checking first for the B0 logic signal, which enables the diodes to pass the broadcast band. At the moment we're on 1.6 megs, which is an amateur band frequency, and there you can see, when I get my meter on it, that the preamplifier is switched on. And if I get down between the board, a bit difficult through the camera, that's actually the point where B0 would appear, and that's at 0 volts, which is correct. Now if I come to the front panel and I just nudge the frequency down to 1.5, you can see that B0 logic signal has appeared at 9 volts, and if we check the preamplifier, you see that that's now gone to 0 volts. So it would appear that the logic switching is working correctly, and the next thing we're going to do is inject a signal, and we'll be ejecting a signal. You look at my crude diagram, this is the resistor we can access through the top. So if we inject a signal here, we should find that at a fairly modest microvolt level, we would get that signal going through there, and that'll tell us whether the problem is after that stage, which is not likely because they're all common to both bands, or it's before that stage. And it's looking very likely at the moment that it's going to be this diode, which is on the underside of the board. So again, I'll set that up and I'll get back in one moment. So to reiterate, we've set up the signal generator now for 1.5 megahertz. We're going to inject a signal here through a 0.1 capacitor. You can see that the top display, in this case the bottom one upside down, is set at 1.5 megahertz. We're just going to clip on the signal. The signal generator we set for 2.8 microvolts, and if we can hear that, we'll just try and probe this without shorting things out. This side of the wire, and there you can hear a scratchy signal, but again we're only putting in 2.5 microvolts at 1.5 megahertz, so that shows that the sensitivity from this point forward is okay. So the deafness is back here, and the only thing that that can be is this pin diode D801, which is on the underside of the board. But before we actually go to the trouble of taking the board out and removing it, I'm going to check that we've got one in stock first. It's better not to have radio sets in bits and pieces all over the place. It's better to have the parts here if at all possible. So I'm going to go and check stock. I'll be back with you shortly. So looking at this transmitter problem, you may recall that the transmitter shuts down when the tuner is engaged, whether you make it tune or you just switch it into circuit, and it appears to be drawing excessive current, which is why it's shutting down. So we've changed the test setup. We've got the output of the transceiver coming into a bird through line because that reacts much quicker than the test set, and then that's going off to the dummy load and into the test set. So the frequency in use at the moment is 28.66. So if I press transmit now, you can see on the spectrum analyzer virtually on frequency, right in the middle is the carrier wave. We're only running about 5 watts there, but watch what happens when I put the tuner in. I'm just going to click it in. It changes frequency, and that's gone up to 34.9 megahertz. So the something weird is causing the radio to change frequency, and it's going to a frequency that's outside the bandpass filters. So the SWR is probably way high once it's gone outside the band. which is why it would be drawing excessive current. So what we're going to do, we've set up the second test set on 28.66, and we're going to use that to drive the PA externally to see if we get the same effect when we remove the actual drive. Because what we need to know is it an RF feedback problem that is getting back into the synthesizer board and causing it to change frequency, or is it parasitic oscillation somewhere? So I'll set that up. Basically all we're going to do is unplug the cable that drives the PA amplifier, which is this one. In fact, I might be able to do it one-handed while we're talking. And we're going to clip on the coax cable that's coming from the second signal generator. So now we're going to put it on transmit and ignore the baseband signal, but you can see that the carrier is steady in the middle. And now I'm going to switch the tuner in. So that's the tuner gone in, and you did see a spike at 34, which is really odd, but it's not there now. Switching the tuner out and then switching it back in again. Yeah, it does look kind of peculiar, but it's not actually shutting the set down. I'm not able to control the power because the APC loop's broken now. But the carrier going out there is a steady 20 watts, and all looks well. The tuner's engaged, so all is well with the world. So it's rather odd, and that's it off again. So I'm going to hook it up again and do another test. Stand by. So the configuration is back to how it should be, with the internal oscillators of the set driving the PA, and we're going to transmit, and you can see the carrier in the center. I'm now going to switch in the tuner, and off she goes to 34 point odd megahertz. The screen's gone blank, although we are still flashing the tuner and stuff, but we are taking 20 amps on the power supply. So obviously that PA has gone full out for some reason when the tuner is engaged. So like all good radio engineers at this point, I'm going to go and put the kettle on and have a think about that one. Well, it's a new day, and been pondering the problem, bit of lateral thinking, and here's the solution to that problem, I believe. Now the only way you can get parasitic, well, the only way you can get the frequency to change at the transmitter, there are two reasons. One is the synthesizer is letting go, so it's not controlling the frequency, and in that case you would get an out of lock alarm coming up from the associated logic with the synthesizer, or the power amplifier device is going into parasitic oscillation, and to do that it needs feedback. You need to form a loop so the output can get back to the input and the thing would oscillate at its own resonant frequency. And to some extent the bandpass filtering will influence what frequency that takes off at. Now going back to our original problem, the switching for the broadcast band frequencies, which are not transmittable, i.e. you can't transmit down in the broadcast band, we decided that here's the block diagram again, so the path from the antenna is common to both transmit and receive here at the switch bandpass filters, but this diode and this diode isolate the broadcast band circuit from the transmit circuit, and we know that that diode is okay, and we can get a signal from there forward, and we know that this diode has stopped working, although we've not had the board out yet, because we don't have the parts in stock. But what I reckon is this diode has stopped working, but it's still acting as a capacitance, and without being reverse biased, there's not enough isolation of that particular circuit when you're transmitting, and that line rejoins back here just off the page. You can see the orange light coming here, so I think we're getting a loop between the transmit power here through that circuit and back around through the bandpass, and that's what's causing our parasitic oscillation in the PA. So what we have to do now is wait. It's New Year's Eve, so it's going to be at least 5 days before those diodes come into stock, and then we'll pop them in and make a video to finish the job off. So with that, we wish you all a very happy and healthy new year, and we're back in 2020. Okay, so the diodes came into stock and I've stripped the board. I'll show you more about that later, but this is the actual fault. You can see that the meter here is reading 60k, 60 kilo ohms, and what we're across, in fact I'm going to shut this video down and try and zoom in on that, and I'll come back to you. Okay, sorry about that. It's a fairly old camera and it won't focus if you zoom, so there you go. The component we were actually measuring is this resistance here, and that feeds D801, the one that the diode we theorised was causing the problem by providing too much feedback. In fact, it wasn't being biased at all, so you know, that's certainly the problem on the broadcast problem. So that resistor, I can't get any closer because the camera won't focus, but is reading 60k instead of 100 ohms, and we'll take a look at that again on the diagram. So there you go. I'll have to try and find a resistor and put it back together. Slight change from the video I shot previously, in that we found that all the components we needed to get to were underneath the RF amplifier, which is this board. Again, we're not getting very good focus here. RF amplifier, which we've had to take off, and also the switched filters, which is this board. And I found that a solder sucker is not really good enough to get all the solder off these pins to free the boards up, and I've used solder wick, which you've got to be a bit more patient with it, but the boards are so fine you don't want to risk damaging them. So we'll jump up to a circuit next, and then we'll change the 100 ohm resistor if we've got one, and put it all back together and see whether we've cured the broadcast receive problem, if not the transmitter problem. So back with you shortly. Okay, you may recall from the video segments earlier that I drew this larger diagram to explain what's going on. So the broadcast frequencies, i.e. non-amateur radio frequencies, come through this network from left to right and are switched or enabled by putting current through the 2-pin diodes here, D801 and D802. And it also goes through a attenuator and a filter on its way. Now these diodes, in order to switch, you can consider them as a switch, need current going through them, and that current is provided by logic signal B0, which is here, and that goes through R801 that way, through that diode, and R803, which puts current that way through that diode. And you may recall we injected a signal here, and that signal went forward, I think it was about 8 microvolts, was it 2 microvolts from memory, and that was fine, you know, good reception. So we theorised that this pin diode is either not switching or is acting as a capacitance, and that's providing a feedback loop which caused the whole PA to go into parasitic oscillation. You may recall that the frequency changed on the spectrum analyzer when we engaged the tuner. So having delved into the circuit, we then measured this diode at about 25k ohms. So it's not working as a diode at all, and indeed that would be either resistance or capacitance in this circuit. R801, which measured 60k, as you saw, was actually open circuit. The 60k was just residual. So that's gone open circuit, and the inline 68 ohm, which is part of the attenuator network, had also gone open circuit. So it looks like it may have been a heavy static discharge that's coming this way, blown the diode, burned out that resistor and that resistor. Or it could be that this radio is operated in close proximity to other HF radios, and again you've got a very large signal which has broken down that diode and burned out that resistor and that resistor, and from there on it was AC coupled. So if it was RF, obviously it would go through the capacitor and down, seeking earth down through this network and that network. So we've put a diode in. We didn't have any 1SV801s, so we put a bar 68 in, which is a similar specification, slightly lower capacitance, and sadly we've not got any resistors in the physical size that we need, so they again have been ordered. So a few days will pass, and then we'll hopefully put the resistors in and put the radio back together and do the final testing. Certainly that's the cause of the broadcast radio signals not getting through, and hopefully we'll find it's also the cause of the mysterious frequency change when the tuner is engaged when the transmitter is operating. So again we'll finish this video off in a few days when those parts come in. Right, already conscious this is quite a long video. It may not even upload, but we'll see. So the radio set is back together. We've changed the pin diodes. We had changed 3 of them to make them all the same. Put the 2 burned out resistors in, and here we go. So we're set at 1.94 megahertz. So the signal generator is 1.94 megahertz at 1 microvolt on SSB, and you can hear 1 microvolt. We'll put the preamp in a bit louder, and the second stage louder still. And try the attenuator. Yep, that's working. So we're going to just go out of that band down to the broadcast band, which is where we had trouble. So we'll say 1.5 megahertz and go up to the signal generator, dial 1.5. And of course we need more signal in the broadcast band because the attenuator that we were having troubles with has come into play. So we're going to go up to 10 microvolts, and here you can see that signal, not quite zeroed, got it locked as well. There you can hear it. So that's okay for the broadcast bands. So now we're going to just try the transmitter, see if that works correctly now with the tuner in. So we're going to transmit. There we're on transmit, and the tuner's engaged. So remember it's shut down last time. Let me just move that from to power out, and then put the tuner in, and it's not shutting down. Come out to transmit, select 24 megs, transmit again, put the tuner in, and so we seem to have cured all the problems. So there you go. For those of you not worked with surface mount, I've put a still picture at the end of the video to show the size of the components, just for interest's sake, and I hope you enjoyed this video. ZL1PNY is signing out.